In this video, we will learn solution of linear differential equation with constant coefficients.
Consider linear differential equation a naught into dny by dx raised to n plus a1 dn minus 1y by dx raised to n minus 1 plus a2 dn minus 2y by dx raised to n minus 2 plus so on an minus 1 y an minus 1 dy by dx plus an y equal to 0. This differential equation is linear differential equation. If all the coefficients a0, a1, a2, a3, an are constant, then this differential equation is called as linear differential equation with constant coefficients. Called as linear differential equation with constant coefficient. There are so many methods of solving linear differential equation. We will say first method. If you consider y equal to e raised to mx, then dy by dx equal to e raised to mx into derivative of mx is m. dy by dx equal to m e raised to mx. d square y by dx square equal to m into m, that is m square e raised to mx. Similarly, dny by dx raised to n is equal to m raised to n e raised to mx. If I substitute these values here in first equation, then what I will get? A naught into nth derivative of y, that is m raised to n e raised to mx, plus a1 into n minus 1 derivative. N minus 1 derivative is m raised to n minus 1 e raised to mx plus a2 n minus second derivative m raised to n minus 2 e raised to mx plus so on an minus 1 dy by dx m e raised to mx plus an into y. Y is nothing but e raised to mx equal to 0. From this equation, I can take e raised to mx common and I will get a naught m raised to n plus a1 m raised to n minus 1 plus a2 m raised to n minus 2 plus so on an into e raised to mx equal to 0. This will be 0 if and only if this bracketed term is 0. It happens if a naught m raised to n plus a1 m raised to n minus 1 plus a2 m raised to n minus 2 plus so on an equal to 0. If we represent this equation 1 by f dy equal to 0, then this equation can be written as fm e raised to mx equal to 0. And this shows that e raised to mx is a solution of the differential equation 1 if Fm equal to 0. Thus, we can conclude that e raised to mx y equal to e raised to mx is a solution of linear differential equation with constant coefficient f dy equal to 0 if and only if Fm equal to 0. And the solution will be e raised to mx. That are the roots of Fm equal to 0. Now let us solve some problems on this. We shall write some notes. First note, if degree of differential equation is n, then Fm is of degree n, and therefore it has n roots. This Fm equal to 0, we shall call this as auxiliary equation. And this auxiliary equation has n roots. That means if degree of the differential equation is n, then auxiliary equation has n roots. And they may be m1, m2, m3, so on, mn. They are all real numbers or complex numbers. They are maybe real, equal, or they may be distinct. There are so many cases. We shall consider first case. All these mi are distinct. All these roots are distinct. If all roots of auxiliary equation are distinct, then e raised to m1x, e raised to m2x, e raised to m3x, and so on, e raised to mnx are the solutions of this differential equation. And we shall write one general solution as y equal to c1 into e raised to m1x plus c2 into e raised to m2x plus c3 into e raised to m3x plus so on cn into e raised to mnx. Thus, if degree of differential equation is n, then the auxiliary equation has n roots and there are n solutions, e raised to m1x, e raised to m2x, e raised to m3x, e raised to mx, if all the roots are distinct. And its general solution can be written in the form of y equal to c1 e raised to m1x plus c2 e raised to m2x plus c3 e raised to m3x plus so on cn e raised to mnx. Now we shall solve some problems on this. Example 1, 3d cube plus 5d square minus 2d into y equal to 0. We have to solve differential equation 3d square plus 3d cube plus 5d square minus 2d equal to minus 2d into y equal to 0. Now its auxiliary equation is three m cube plus 5m square minus 2m equal to 0. This is auxiliary equation. From this we can take m common throughout. 3m square plus 5m minus 2 equal to 0. Thus we can write m equal to 0 or 3m square plus 5m minus 2 equal to 0. Now for finding factors of this, coefficient of m square is 3 and this is a 2, therefore product is minus 6. Therefore, there must be the factor whose difference is 5. That are 6 and 1, and 6 minus 1 equal to 5. Therefore, this term can be written as 3m square plus 6m minus 1m minus 2 equal to 0. From this we can take 3m common. From this we can take minus m common, minus 1 common, and therefore m plus 2 into 3m minus 1 equal to 0, and therefore m equal to minus 2 and m equal to 1 by 3. Thus we get 3 roots: m equal to 0, m equal to minus 2, m equal to 1 by 3. Thus general solution is y equal to c1 e raised to 0x plus c2 e raised to minus 2x plus c3 e raised to 1 by 3x. Solve d cube plus 6d square plus 11d plus 6y equal to 0. For this equation, auxiliary equation is m cube plus 6m square plus 11m plus 6 equal to 0. For finding root of this cubic equation, we shall use randomly, we shall put m equal to 1. But if we put m equal to 1, all terms are positive, it will never become 0. Therefore, we shall try to check m equal to minus 1. Therefore, minus 1 cube is minus 1. Minus 1 square is plus 1. Plus 1 into 6 is 6. Minus m is minus 1. Minus 1 into 11 minus 11 plus 6. 6 and 6 12. 11 and 1 12. 12 minus 12 equal to 0. Therefore, m equal to minus 1 is a first root. As m equal to minus 1 satisfies this equation, m equal to minus 1 is first root. Now we shall use synthetic division. We shall divide this polynomial by synthetically by m equal to minus 1 or m plus 1 equal to 0. Coefficients are 1, 6, 11 and 6. I shall carry 1 forward as it is. 1 into minus 1 is minus 1, minus 1 and 6 5. 5 into minus 1 is minus 5. 11 and minus 5 is 6. 6 into minus 1 is minus 6. And 6 minus 6 equal to 0. Therefore, second polynomial is m square plus 5m plus 6 equal to 0. Now 6 can be factorized as 3 into 2, such that 3 plus 2 equal to 5. Therefore, factors are m plus 2 and m plus 3. Therefore, m equal to minus 2 and minus 3, and first root is m equal to minus 1. Therefore, general solution is y equal to c1 e raised to minus 1x plus c2 e raised to minus 2x plus c3 e raised to minus 3x. This is the required general solution. We have to solve the problem d cube plus 3d square minus 4d minus 12y equal to 0. Its auxiliary equation is m cube plus 3m square minus 4m minus 12 equal to 0. Now we shall use a trial and error method. For m equal to 1, this is not equal to 0. For m equal to minus 1 also not equal to 0. If you take m equal to minus 2 cube minus 8, minus 2 square plus 4, 4 into 3, 12, minus 2 into minus 4 plus 8 and minus 12. 12 and 8, 20, 8 and 12, 20, 20 minus 20 is 0. Therefore, m equal to minus 2 is the first root of this polynomial equation. Now, we shall divide this polynomial synthetically by m plus 2. Therefore, minus 2 we shall write here. 1, 3, minus 4, minus 12. We had written coefficients. 1 is carried as it is. 1 into minus 2 is minus 2. Minus 2 and 3, 1. 1 into minus 2 is again minus 2. Minus 4 minus 2 minus 6. Minus 6 into minus 2, 12. 12 minus 12, 0. Therefore, quadratic equation is m square plus m minus 6 equal to 0. This 6 has the factors 3 into 2, so that 3 minus 2 equal to 1. Therefore, m square plus 3m minus 2m minus 6 equal to 0. From this you can take m common, m into m plus 3. From last term we can take minus 2 common, m plus 3 again. Therefore, m plus 3 into m minus 2 equal to 0. m equal to 2 and m equal to minus 3. And first root is minus 2. Therefore, general solution is y equal to c1 e raised to minus 2x due to this minus 2 plus c2 e raised to 2x plus c3 e raised to minus 3x. This is the required general solution of the given differential equation. d cube minus 7d plus 3y equal to 0. Now, we have to solve the problem 4d cube minus 7d plus 3y equal to 0. For solving we need auxiliary equation. Therefore, auxiliary equation of this differential equation is 4m cube minus 7m plus 3 equal to 0. For solving cubic polynomial, if we put m equal to 1, 4 plus 3, 7, 7 minus 7 equal to 0. Therefore, m equal to 1 is the first root. We shall divide synthetically this polynomial. M equal to 1 is here. Coefficient of m cube is 4. Coefficient of m square term is absent here. Therefore, we shall take it as 0. Minus 7 and 3. I shall carry this 4 as it is. 4 into 1 is 4. 4 plus 0 is 4. 4 into 1 is again 4. 4 into minus 7 is 4 and minus 7 is minus 3. Minus 3 into 1 is minus 3. Minus 3 and 3 is 0. Therefore, second polynomial is 4m square plus 4m minus 3 equal to 0. This is the second quadratic equation. Now, for finding roots of this quadratic equation, 4 into 3 is a minus 12. Minus 12 can be factorized as 6 into 2, so that 6 minus 2 equal to 4. Therefore, 4m square plus 6m minus 2m minus 3 equal to 0. From this I shall take 2m common. Two m common. 2m plus 3 will be there. Again I shall take minus 1 common. 2m plus 3 is there. Therefore 2m plus 3 and 2m minus 1, these are the factors, and therefore m equal to minus 3 by 2 and m equal to 1 by 2. These are the two roots of this quadratic equation, and m equal to minus 1 is the first root. Therefore general solution is y equal to c1 e raised to x plus c2 e raised to minus 3 by 2x plus c3 e raised to 1 by 2x. This is the general solution. We have to solve the problem 4d cube minus 13d minus 6y equal to 0. We shall write auxiliary equation of this differential equation, that is a 4m cube minus 13m minus 6 equal to 0. Now if I put m equal to 1, 1 cube 1, 1 into 4, 4 minus 13 and minus 6, it is near 0. But if I take m equal to 2, 2 cube 8, 8 into 4, 32, minus 13 into 2, 26, minus 6, 26 and 6, 32, and 32, 0. Therefore, m equal to 2 is the first root of this cubic polynomial. For finding other roots, we shall divide synthetically by m equal to 2, 4, coefficient of m cube, m square term is absent, therefore we shall reckon 0, minus 13, minus 6, 4 is carried as it is, 4 into 2, 8, 8 plus 0 is 8, 8 into 2, 16, 16 minus 13, 3, 3 into 2, 6, 6 minus 6, 0. Therefore, second quadratic equation is 4m square plus 8m plus 3 equal to 0. Now 4 into 3 equal to 12, and factors of 12 are 6 into 2, such that 6 plus 2 equal to 8, middle term. Therefore, I shall write this as 4m square plus 6m plus 2m plus 3 equal to 0. And therefore, 2m is taken common from first two terms and plus 1 is taken common from last two terms, and therefore 2m plus 3 into 2m plus 1 equal to 0. Therefore m equal to minus 3 by 2, m equal to minus 1 by 2, and first root is 2. Therefore general solution is y equal to c1 e raised to 2x plus c2 e raised to minus 3 by 2x plus c3 e raised to minus 1 by 2x. Our problem is solve d cube x by dt cube plus d square x by dt square minus 2 dx by dt equal to 0. We shall put d by dt equal to capital D. Therefore, our problem becomes d cube plus d square minus 2d y equal to 0, whose auxiliary equation is m cube plus m square minus 2m equal to 0. We can take m common, m square plus m minus 2 equal to 0. M equal to this minus 2, therefore m equal to 0, or m square plus m minus 2 equal to 0. For solving this equation, 2 can be factorized as 2 into 1, so that 2 minus 1 equal to middle term 1. Therefore, m square plus 2m minus 1m minus 2 equal to 0. M is taken common, m plus 2 minus 1 is taken common, m plus 2 equal to 0. Therefore, we will get m plus 1, m plus 2 into m minus 1 equal to 0. And therefore, m equal to 1 or minus 2. And first is m equal to 0. Therefore, general solution is y equal to c1 e raised to 0x plus c2 e raised to 1x plus c3 e raised to minus 2x, that is equal to c1 e raised to 0x is 1 plus c2 e raised to x plus c3 e raised to minus 2x. We have to solve the problem d cube x by dt cube minus 19 dx square x by dt square plus 30x equal to 0. In this, we shall put d by dt equal to capital D. Therefore, d cube minus 19d square plus 30x equal to 0. Its auxiliary equation is m cube minus 19m square plus 30 equal to 0. If I put m equal to 1, it will never become 0. For m equal to 2, 2 cube 8, 2 square 4, 76 and 30. We have to solve the problem d cube x by dt cube minus 19 dx by dt plus 30x equal to 0. We shall put d by dt equal to capital D. Therefore, problem becomes d cube minus 19d plus 30x equal to 0. Its auxiliary equation is m cube minus 19m plus 30 equal to 0. If I put m equal to 1, it will never become 0. For m equal to 2, 2 cube 8 minus 19 into 2, 38 plus 30. 30 and 8, 38 minus 38 equal to 0. That's why m equal to 2 is the first root of this cubic polynomial equation. Therefore, we shall divide synthetically by m equal to 2. Coefficient of m cube is 1, coefficient of m square is 0, coefficient of m is minus 19, and last term constant term 30. 1 is carried as it is, 1 into 2, 2, 2 plus 0 is 2, 2 into 2, 4. 4 and minus 19, minus 15. Minus 15 into 2, minus 30. Minus 30 plus 30 is 0. Therefore, second quadratic equation is m square plus 2m minus 15 equal to 0. This 15 can be factorized in such a way that this sum is, their difference is 2. 15 can be factorized as 5 into 3. So that 5 minus 3 is equal to 2. Therefore, m square plus 5m minus 3m minus 15 equal to 0. m is taken common. m plus 5 minus 3 is taken common. m plus 5 equal to 0. Therefore, m plus 5 into m minus 3 equal to 0 and m equal to 3 and minus 5. First root is 2. Therefore, general solution is y equal to c1 e raised to 2x plus c2 e raised to 3x plus c3 e raised to minus 5x.